no math in math class today. So then that pushed you further behind on getting all the math done for the end of the year. And then how is pre-calculus or your next math class going to go if we don't cover all the things? So we don't want that. Okay. Well, I did have to take some points away. I do have some positive things to say. So this is a nice thing. You're going to appreciate this. According to my notes, I believe, let me confirm that.
Yeah, she wrote.
You don't want to talk about it.
No, I'm not talking about
According to my notes, everybody has page 2 and page 3 completely done. Or most of it done. Everyone at least tried on page 2 and page 3. So therefore, I'm going to give everyone points for page 2 and page 3, and I know. She didn't specifically call someone out by name for not trying to get math done, so everyone's going to get points for trying to get math done yesterday. I do want to look at page 3, though, so if you'll go ahead and turn to that, and at least fake pretend you have it done. If you don't want me to know, because then I'd be tempted to take the points back.
get our check points in the...
Yes, they're in the drawer. And it's funny you mention that. You can have a point for that. We have a lot to do today. More than likely, I'm going to ramble so long, we're not going to get to the checkpoints from yesterday. That's going to be tomorrow's problem. So make sure, if you didn't already get your checkpoint done, you would like to have it done by tomorrow, because that's tomorrow's problem, to make sure we pass it. Also, bring your workbook tomorrow. I'm telling you, we're doing a workbook page tomorrow, so if you normally leave it at home, bring your workbook tomorrow. Yes, dear? Let's do that at the end of class, yes, and then yes, I have extra checkpoints too. But seriously, the checkpoint's going to be Friday's problem. So it's fine if you didn't even get it, like it's Friday's problem. It's not Thursday's problem. Yes, dear. I need to give you one. Remind me of that tomorrow. I'll get you one out the closet. That's easy. Okay, back to the worksheet on page 5. I told you can skip 19 and 20. We'll talk about those in just a second. Does someone have a question on a number other than 19 or 20? Let me guess, 18?
Yeah.
Okay, anyone else have a question other than 18, 19, 20? Yeah, I'm going to let you. What say it, Landon?
16 has 12 equals 12. Do we just do it like that? Or
Yeah, and we have one in our notes like that, so you literally don't have to solve anything. That one's done for you. That's good. I have a point for that, Landon. Travis, are you wanting to give me the answer on 19 and 20? Or on 18? Okay, hold on one second. Let me answer his 18 really fast, and then I'll let you do 19 and 20. Okay, 18, you're good with everything but Z, right? Z is what you're mad at. So on 18, letter Z, the last one, so 8Z equals 4Z. Lyric, if you don't have this packet, look in 1017.
I got it.
Okay, good. Okay, so 8Z equals 4Z. Let's subtract 4Z from both sides. I've got 4Z equal to 0. If I divide by 4, I end up getting Z equal to 0. But to be honest, I kind of knew that in my head anyway. Is what number could I plug in to make 8 equal 4? Because I thought I'd plug in maybe a half, because 8 divided by 2 is 4. But then it would be 4 divided by 2, which is 2. So as 8 goes down, 4 goes down. As 4 goes up, 8 goes up. The only way this would work is if Z is 0. So I kind of knew that in my head anyway. But I appreciate you asking that, which is why I already gave you a point for it. I pray. If I didn't, you need one. Okay, on number 20, I have some people interested in sharing their answers, which, let me check my key again. Travis, you had an answer for 19 or 20? And X equals
3.
Okay, you get a point for that. And then number 20, yes.
X equals 12, y equals 3.
Yes, you can get a point for that. Okay, so my brave souls who actually follow directions, bless them. Bless them. So, yes, table 2, take a point away. Yes, I'm supposed to set x equal to 4y. I'm supposed to set 3y equal to x minus 3. And then we're annoyed because for the first time ever with matrices, we have 2 equations with 2 variables. It's a good thing we just took a test on how to solve this kind of a problem. It's great for substitution. Everywhere I see an x in the second equation, I'm going to put 4y. So it used to be 3y equals x minus 3, but x is equal to 4y. So I'm replacing x with 4y. When I subtract 4y from both sides, I end up with negative y equals negative 3, so y ends up equaling just positive old 3. when I plug it back in, you can plug in either equation. I'm going to do the top one just because it seems easiest. So x equals 4y, y is 3, so 4 times 3, so x equals 12. So 12, 3 is our answer. Are there any questions on number 20? I get you weren't brave because I wasn't here, but from here on out, just because it involves substitution doesn't mean you can't do it. You just took a test on substitution. You can handle it. Okay, 19 says 2x equals 6y, y plus 2 equals 6x. The second one's already set up for us. Everywhere you see an x, put y plus 2. So in the top equation, instead of 2x equals 6y, I've got 2y plus 2 equals 6y. So 2y plus 4 equals 6y. 4 equals 4y. Y ends up equaling 1. When you plug that back into either equation, I picked the bottom one because it just looks easiest. 1 plus 2 equals x, so that means x equals 3. Again, they weren't earth-shattering, but they were a little tedious. So it's okay if you skip them, but now we know what to do. Okay, let's go to our math workshops and go ahead and get those out of the way. We're going to do 1 through 4 today. We're going to finish the rest of this workshop sheet. Good grief, that word almost came. We're going to finish the rest of this workshop sheet tomorrow. So if you're wanting to be ahead for your group, get 5 through 8 and 14 done as well. Okay, I saw Andrea. You want to help me with number 1? Go ahead, tell me. That's perfect. She pulled out a GCF. She can get a point for that.
And then I got 16x cubed plus 5y.
Perfect. So it was 2 terms. She asked herself, is there a GCF? She pulled out a 12xy. She's left with a 16x cubed and a 5y to the 4th. Yes, dear.
Number 2, x squared plus 3 minus 5.
Okay, what process are you using, Brady? I'll give you an extra point for that. And you can have 2 points. So he was doing grouping. He pulled out an x squared, was left with an x minus 5 from the first group. He pulled out a 3 from the second group, was left with an x minus 5. He's happy because the x minus 5's match. So his final answer is x squared plus 3, x minus 5. And he got 2 points for doing the process, yes, but also knowing the name was grouping. That got him a whole nother point. Y'all are all volunteering. What happened to number 3? Oh, every class read's been behind. I'm really impressed y'all already handled 1 and 2. I'm so impressed every group got out a point.
Let's see. Yes, we have 0 points.
There you go. You're almost there.
You do the,
You do the multiplying.
Yes, Landon. Yes, Landon. You got the whole explanation out first, although Caitlin was dead on your heels, so we'll give her a point too. And the reason I know I can do that is because the GCF is, because the leading coefficient is 1. Because it's 1a squared minus 3a minus 4, this works. So I'm needing 2 things that add to give me that middle term, so a negative 3. Multiply to give me the last term, so a negative 4. What 2 numbers add to negative 3, multiply to negative 4? Negative 2 and negative 1, when you put them together, they multiply. You're not going to get 4.
Negative 1 or negative 2.
Wouldn't it be
What things multiply to 4?
Oh, negative 4 plus 1.
Yeah. So it was either, our options were 4 and 1, because that multiplies to 4, or 2 and 2, because that multiplies to 4. I got to go with 4 and 1, because negative 4 plus 1 is negative 3. Negative 4 times 1 is negative 4. So it's negative 4 positive 1 landing in a point. Number 4 looks to be our hardest. How many terms are there?
1.
There are 2 terms. You're right about that. I'm not mad at y'all for that. I was trying to give Mason a point. I looked directly at him, and he was zoned out. It's okay. Oh, I'm trying again. It doesn't matter. It's just, I like to think through. If there's 3, it's normal factoring. If there's 4, grouping. If there's 2, I can try GCF. There is no GCF, so I want to say I'm done, but that would be wrong. Don't steal my joy, Grady. Let me see if he can get this before you answer it. 81 is a beautiful number because it is a what?
Perfect square. Add a point.
I will give 1 and 3 a point. I was trying to give 1 a point. 1 and 5 a point. Sorry, not 3. 1 and 5. Okay. Brady, you want to tell us what the answer is? Okay, anytime you see a perfect square number like that, especially when there is a minus sign, anytime you see it set up like this, so minus 81, minus 144, minus 100, it ends up being the 2 numbers that make up that perfect square, but with opposite signs. Now, why does that work? Because if we were to FOIL this back out and check ourselves, first we would get d squared. Outer would be positive 90. Inner would be negative 90. Positive 90, negative 90, they cancel out. So the outer and inner get rid of each other. So we just have first d squared and last negative 81. Always works like that. So number 8 is going to be another beautiful one like this. If you want to put a star by it and probably handle it now while I answer Landon's question. Yes, Landon?
That's how you do it. But if it was just d instead of d squared, would you just do it like that?
Yeah, it would be over. It has to be squared, yes. Because you're right. If it was just d, what are we going to do when we, what would you do? Square root of d? Like square root of d minus 9? Square root of d plus 9? And who really wants to do that? So, I agree. Okay, let's go to your packets. We're on page 5. It's the page behind the worksheet you had to work on yesterday. So while you're doing that, I'm going to tell you today is a great day because we get to use these with matrices. So if you want to come get a graphing calculator right now, that's fine. I'm also going to be very colorful, so if you want to get out colors, that would be great too.
Sarah.
Okay, so the coolest thing happens today. We get to multiply matrices. So let's talk basically about matrix basics. So a matrix is made up of different numbers, or it can be variables. They're called elements. You have to decide the dimensions of a matrix. Now, let's look at number 1 and pretend it's addition. If it was addition or subtraction, life works exactly like you think it should. You would add the first entry and the first entry. So 4 plus 3 and get 7. Addition and subtraction worked exactly like you wanted. Multiplying by a constant on the outside, which we call a scalar, worked exactly like you wanted. Life was great yesterday. And life's still going to be great today, although multiplication is a little bit harder. We're not going to do just 4 times 3 and put 12 as the first entry. There's a little more to multiplication than what we were doing yesterday. However, what we've been doing is going to help us. So I need to go through and label the dimensions of each of these matrices. For instance, number 1 is a 2 by 2 and a 2 by 2. Let's give each group a chance. Table 1, what's number 2?
On what page is that?
5. And you know the dimensions of the 2 matrices.
2 by 2.
And
2 by 2.
you can have a point. Alright, table 2, number 3. That is correct, and you can have a point. Table 3, number 4. 2 by. Thank you. You have a point. Table 4, you want number 5? You can be table 5. We'll let you finish it. We'll go back to them. That's fine. Finish the other one. 3 by 2 and 2 by 2. She had it right. We'll give her a point. Braden's table. Y'all hand her number 6 then?
3 by 2 and 2 by 2.
Perfect. And you can have a point. And they're happy you did that. They got an easier one. They appreciate that, to be honest. Number 7, table 6. Crickets.
3 by 2.
And
1 by 2.
1 by.
Oh, 1 by
How many?
3.
1 by, that one was actually hard. It's a 1 by 3. We'll give you the point. We'll give you the point. And they didn't have enough space. Darn word. Darn word. So it's 1 row, but 1, 2, 3 columns. So it's 1 by 3. It was 1 row and 3 columns, like zeros in 1 column, 4s in 1 column, negative 3s in 1 column. So it's a 1 by 3. I know what you're going to say, and I'm about to say that, so let me finish my things. Okay, number 8, table 1, we're back at you. It took too long, table 2.
2 by 2.
Have a point. Table 3.
3 by 3, 3 by 3.
Okay, we're going to give table 4 first dibs on this question. I think they're going to know the answer. In fact, let me ask Layden's question. Yesterday, if you had the dimensions that we have on number 7, would you have been able to add or subtract? No, we would have put not possible. Okay. And then another easy question that I'll let table 5 handle. What's it called? There was a term for it when it's a 2. She is like, oh, my page. A 2 by 2, a 3 by 3, and it's a square. And that's my favorite kind. And get a point for that. We're eventually going to need them to be square for the next thing we're going to do. Not multiplying in general, but the next thing we're going to do with multiplying. Okay, so if you want to read all the things above, you can. I'm going to try to give the elementary school version. So when we multiply with matrices, they don't have to be the same dimensions. So yesterday, you couldn't add, you couldn't subtract if they weren't the same dimensions. Like on number 4, because they're not both 2 by 2s, you would say not possible and you're done. That's not the case with multiplication. With multiplication, we actually need the number of columns of the first matrix to match the number of rows of the second matrix. So if the two inside things match, the columns of the first and the rows of the second, if they match, you can do it. There is one problem we're going to put not possible on. What problem is that? Whoa, and you've got to give it to him. He had it first. Number 7. So not possible. Yeah, you know how I feel about the whistling. And then we've got a 2 by 2 and a 3 by 3. So all the other ones are going to be possible because the inside numbers match. Okay, so the inside numbers have to be the same. But the outside numbers are important too. The outside numbers tell you how big the answer should be. So for instance, on number 8, our answer is going to be a 2 by 2. Whereas on number 5, our answer is going to be a 3 by 2. Okay, there are a couple like that they want us to practice. They're up at the very top. They've got letters with them, but that's okay. So I need to know, like, first of all, can we do it? And then if we can, like, the answer would be a what by what. So what's the answer for number 1 up top?
Yes, 2 by 3.
It would be a 2 by 3, thank you. And we can do it because the 4s match. And you can have a point, Brady. Number 2, not possible. Drea's group gets a point, and Landon was there too, because 4 and 5 don't match, and the insides don't match, so it's not going to happen. Number 3, Abby Grace's group gets a point. The 6s match on the inside. Our answer would be an 8 by 10. Thank goodness all our answers are like 2 by 3s and 1 by 2s and not any 8 by 10s. That would be 8 rows, 10 columns. That's a lot of information. Okay, so the first thing we do is we look at the dimensions. Because if the inside numbers don't match, there's no need to waste our time on that problem. After we've looked at the dimensions and we've made sure the inside numbers match, we know what our answer is going to be. Now we can actually multiply. Here's where the colors come in. So when we multiply, to figure out this top entry, we actually do the first row of the first matrix times the first column of the second matrix. So we're going to do this number times this number, and then add this number times this number. So first row, first column, first entry. First row, second column gives us that top right entry. Second row, first column gives us the bottom left. And then second row, second column gives us the bottom right. So we're going to multiply rows times columns to help figure out each of these 4 entries. So first row, first column, first entry. And then, like, it makes sense. Second row, last column, that's going to be the bottom entry. It's going to be okay. We're going to do a couple. And then when we get to number 5, we're going to learn how to use the calculator. So number one, I already know my answer is going to be a 2 by 2. I actually need to draw 2 matrices. I already know my answer is going to be a 2 by 2. And when I start off, because it's our first day multiplying matrices, I'm going to show all my thoughts. But eventually, Derica is going to be so smart, she's not really going to even show work for these. She's just going to go straight to the answer because she does math in her head. Okay, so if I multiply the first row times the first column to get that first entry, I'm going to do 4 times 3, which is 12, plus 1 times 0, which is 0. So my very first entry is a 12. 4 times 3 plus 1 times 0, that's how I'm getting 12. Are there any questions about that first element? Okay, well then I'm going to go first row, second column for that second entry. So 4 times 0, that's 0, plus 1 times 3, that's 3. So my second entry is a 3. 0, 3, that's how I'm getting 3. We finally filled up that top row. We've got to go to the second row. Second row, first column. -6 and 0, so -6 plus 0, so I get -6. And then, oh, where's my other color? Sorry. I know I heard you, Travis. You said 10? -2 times 0 is 0. 3 plus 3 is 9. So 0 plus 9, which is 9. Okay, so -2 times 0 is 0. 3 plus 3 is 9. I get 9. If you're smart enough that you're understanding the process without showing the work, go ahead and go for it. By the time I get to number 4, I'm going to be that lazy too, and I'm not going to show any work. But for now, I'm going to show my steps. Okay, were there any questions about number 1? I'm going to walk you through number 2, and then number 3 is going to be on you. So, let's see. Number 2. Bless you. First row, first column, I get -3 plus 0. So my answer is -3. First row, second column, I get -2 plus 0. So my answer is -2. Second row, first column for that bottom left, I get 3 times 3 is 9, and -7, so 9 minus 7 is 2. And then last but not least, where did the fourth color go? I did blue, I did that. Oh, it's green. Second row, second column for my last entry, 3 times 2 is 6, plus 7 times 4 is 28, 6 plus 28 is 34. Are there any questions? That's a 4. The ugliest 4 ever. Are there any questions about how I'm getting those entries? Anyone have an issue with, just tell me which one, I can help you with it.
Okay.
So I did -3 plus 0, I got -3. -2 plus 0, I got -2. 9 minus 7, I got 2. 6 plus 28, I got 34. And it's really just me doing this row column matching all the way down. Okay, I'm going to give you a second. Try number 3. Tell me what you think the answer is when you have it. Okay, let's go through it again. And so Let's go to number 3 because I hadn't colored on it and other people were working on it anyway. Yeah, what's your answer?
7 for top left, -2 for top right, -6 bottom left, and 6 for bottom right.
7 was correct. No, for the others. Yeah, it's 7, -7, and then what's after that? Yes, and you get a point. Okay, so let's talk about it again. And you don't have to use colors if you don't want to. So for this top entry, I'm doing first row, first column. So 9, 3 times 3 is 9, -2. 9 minus 2 is how I'm getting that 7. You good with that one? So top row, first column, 9 minus 2, I get a 7.
Where'd you get the 2?
9 minus 2, because -1 times 2, and that's how I'm getting 7. So then for my next entry in the top, I still want my top row, but I'm going to my next column. So 3 times -1, I get -3. -1 times 4, I get -4. -3 minus 4, I get -7. So you can write it out if you want, but I'm literally doing it in my head. -3 minus 4 is -7. Okay, so we're done with the top. Now we move on to that second row for the bottom two. This row, this column, 6 plus 8, that's how I got 14. And then -2 plus 16, that's how I got 14 again, because 16 minus 2 is 14. Okay. I know it sounds deep, but it's really not that deep. I swear it's not. Try number 4. Our answer should be a 2 by 3. I want to know if you've got either row correct. I'm going to give you a point. There's my remote. Does anyone have either row on number 4? Tell me your answer, Brayden.
The top one, -15,
Mhm.
one, -5.
It's just close one. It's -5. It's +6. +6 plus 1, I get 7. -15, 1, 7. In the bottom row.
Oh.
You can get a point for the top row. What's the bottom row? Travis. I need number 4. I know it's -15, 1, 7. I need the second row. Yes.
Is it 26 -2 and number 12?
And you get a point. Okay, so let's talk about this one. I did first row, first column, so -12 minus 3, I got -15 for my top entry. First row, second column, 0 plus 1, I got 1. This is our first one to have this extra column, so still first row, +6, +1, I get +7. Are there any questions about the -15, 1, 7? It was 0 plus 1, so I got 1. You love anytime there's a 0 in the matrix, because -3 times 0 is 0, 1 times 1 is 1, so 0 plus 1 is just 1. I love when I see zeros in matrices. Suddenly your math's going to be so much easier. Okay, now for the bottom row, I got 20. -2 and -3 is +6, so 20 plus 6, I got 26. 0 minus 2, I got -2. -10 minus 2, I got -12. Are there any questions about number 4? Okay. Do you need to understand how to do this? Yes. Is it that difficult? No. is there potentially going to be a standardized test question asking you about specifics about this, so you have to understand the process? Yes, because any monkey can type in a calculator. So they're not going to ask you about calculator skills. I'm sorry, they're not. However, in any future math class from this is going to need you to understand this process. In fact, I have a lot of math degrees, a lot of college math classes, matrices crazy, which I love, because I like matrices. You know, I love matrices for a reason. So if you take, for instance, linear algebra in college, it's a matrices class. There are lots of like straight up matrices classes for more fun with matrices. So you need to understand the process. However, from this point on, we are going to learn how to use our calculator. So I think what I would do is check myself with a calculator. But let's be honest, what's going to happen is after I show Drea how to do this, from here on out she's going to do it in her calculator, and I've already accepted that. It is okay.
How did you get
Negative 12 minus 3 is negative 15. Negative 12 minus 3. Abigail, negative 3 times 4 is negative 12. 1 times negative 3 is negative 3. Negative 12 minus 3 is negative 15. Do I need to write it out again?
No, never mind.
Okay. So go to your calculator. Turn it on. Since this is my third class for you to do this, there's potential that it's already stored. It's still good practice for you to type it in your calculator. Okay, so there is a button that says matrix. It is in blue. It is under math. How do we get to the blue buttons?
Click second.
I heard Xavier first. Press second. Get a point, Xavier. He did say it first. Second, matrix. Gets you to your matrices. Now, mine already have some typed in, which is fine. Yours might be completely blank. Doesn't matter. We're going to fix it anyway. We want to type in our problem, so we need to scroll over to edit. Now, again, all the capital letters, any of the capital letters we can pick. So you don't always have to store it in A, but for this first time, let's store it in A. So I'm going to press enter. We have to tell the calculator the dimensions of our matrix. So the first one in number 5 is a 3 by 2. So I'm going to press 3, enter, 2, enter. And then I need to type in all my entries. So 3, enter, negative 2, enter, 0, enter, 4, enter, negative 5, enter, 1, enter. And then I check, does what I typed in, does it look like my paper? Yes, it does. I'm doing good. Because a lot of people make typos because they're in a hurry. Make sure you check. Does my calculator match my paper? Every time you press enter after each one. Second matrix, go to edit. Second matrix, matrix is near math.
Okay, I see that.
Okay, scroll over to edit, and then that's when I'm typing all this in.
Gotcha. Thank you.
Okay, there is a potential mistake you can make at this point in life, though. Because, again, we're wanting to, let's be honest, let our calculator multiply for us from here on out. We are. But we want to make sure we're getting the right answers because we're not going to be able to show any work on the test, so we cannot have typos. We cannot. So one typo I've got to remind you to not make. When we want negative 2, make sure you're pressing the negative 2 and not the subtraction symbol. Make sure you're pressing the white one, not the gray one. Or else your calculator is going to say it can't do it, and it's not the calculator's fault, it's your fault. Okay, so we typed in our first one. Now to get out of this screen, we need to type in our second one. Press second, and then quit. Second quit always takes you back to your home screen. It's kind of like your phone when you press the home button on an iPhone. Okay, we need to type in that second matrix. So I'm going to press second matrix, scroll over to edit, and then I'm going to edit letter B. It doesn't matter what second alphabet letter you pick, but it would be silly to pick the same alphabet letter because you'd be typing over what you just did. So I'm going to edit it. It's supposed to be a 2 by 2. So I'm going to tell it 2 by 2. And then I'm going to type in my entries 1, 2, 2, 1. And then life's good. So you're like, that's great.
Wait,
I still have to actually make it do the math. Yes, ma'am.
okay, so I'm trying to do this thing. Do I go to edit?
Scroll over to edit again, and you've got to edit letter B. Okay. So we had the second matrix edit twice in order to type in our two matrices. But now that our calculator knows both matrices, we just need to ask the calculator to do the math. So is there anyone, I know Evergrace is catching up, is there anyone stuck here?
Not yet.
Okay, well, we want to quit, so let's get that off the screen. But since we're wanting to make it multiply matrices, we're going to press second matrix again. So second matrix. This time, we're not going to, that's a good question. We are going to go to math starting Monday, but no, today we don't even have to go that deep. Good thought, get a point. We're literally just going to press enter. So we want A, we're going to press enter on A. Now A is on my screen. Now, if I press enter again, it would show me all the elements of A, but we're not wanting just A. We're wanting A times B. So I've got to press second matrix, scroll down to B, and press enter on B. So it understands I want A and B. And your calculator understands math, so since you've not put a symbol, it understands to multiply. Press enter again, it tells you the answer. So the answer for number 5 is negative 183. Negative 1, 8, negative 3, 4, 4, negative 9. So God bless my calculator. It did number 5 for me. It did number 5 for me. And we're going to go back through and do number 9 in just a second. Okay. Allison is in a hurry. She's not going to lie to me. From here on out, she's going to do it using her calculator. I get that. I get that she is in such a hurry. She's not going to check every single entry over and over again. She's not going to check it twice. There is one thing she should check before she puts that answer on her paper, though. The one thing she should check is back to the answer was supposed to be a 3 by 2. So make sure your answer is a 3 by 2. If your answer isn't the dimensions it was supposed to be, something's gone wrong. So at least check that. Okay, Travis, you had your hand up. You want to answer which one? I haven't even done it, but you can go for it. What'd you get? 24, yes. Negative 15, yes.
14.
Yes.
And negative 13.
Yes. That's correct. Travis, keep doing it in your head then. That's fine. Okay, so I'm going to type in number 9. So second matrix, I'm going to edit. I don't want to use A and B. I'm going to use D and E. I'm going to edit D. I want it to be a 3 by 3. So I'm going to tell it 3 by 3. I'm going to type in all my things. So 2, 0, negative 3, 1, 4, negative 2, negative 1, 3, 1. So I've typed in exactly what I saw on number 1, or the first matrix on number 9, into my calculator. So I've got one of the matrices. Now I've got a second quit and then come back to edit to type in my other matrix. Is there anyone confused about this? Then I'm going to second quit, come back and edit, and I'm going to type it in letter E. It doesn't matter where you type it in at, but Drea needs to know, hey, I put this matrix in D, because if she starts getting confused, she might try to multiply A into something. You've got to keep up with who you typed where. So E is a 3 by 2. It needs to be 2, negative 2, 3, 1, negative 2, 4. Now that I've typed it in D and E, I can second quit. I can do my second matrix. I can tell it to do the math. I want D, which is 4. I want E, which is 5. So D times E. Lo and behold, it did that for me too. So the answer to number 9, 10, negative 16, 18, negative 6, 5, 9. 380.
The bottom right, number 6, negative 17.
Number 6. Yes, he's right. Travis. Bottom right, number 6 would be negative 17. Okay, I get Miss Compton is running low on time. It would be smart of you to practice 6 and 8, typing them in your calculator and make sure you have it down. Honestly, that's what we're doing tomorrow besides the checkpoint. The workbook page is you, and I assume your calculator, you and your brain doing matrix multiplication. Can someone ask me a really good question so I can give them some extra points? It's not homework. Really good. That is a good question. You got a point for that. Do you want me to tell you what I'm thinking? No, you don't have to. It's tomorrow's problem. Someone asked me, hey, Miss Compton, Can I now use that to add and subtract matrices? Yeah. So like, let's see, you want 3 times matrix A? It can do that for you now. It can do all the things we've been doing, and you can just use your calculator. Landon.